Hi, I'm Sam. To give you a bit of background as to who I am and why I'm so interested in TypeScript, I'm going to point to my previous job. So before working at Wise as a senior security engineer, I've worked at GitHub, SEML, and the United Nations OCHA. And these are all very different companies, very different roles, very different technology stacks. But one thing that was common across all of them is that I was able to use TypeScript for a lot of the work that I did. In some of these roles, a lot of companies were using TypeScript already for their Node and browser-related projects. But there were 2 or 3 very, very big projects across these companies that I was involved in large migrations from JavaScript to TypeScript. And these were projects with 5 or 6 full-time developers, many hundreds of files, tens of thousands, hundreds of thousands of lines of code. So it's definitely feasible, I think, to do these sorts of migrations, and I'm going to talk a bit about that today. If you want to connect with me online or follow what I do, I used to tell people my Twitter handle, but I recently shared my Mastodon account on my Twitter bio, so now I'm suspended. So you can find me on Mastodon or directly on GitHub. So let's talk about TypeScript. To help gauge where I should focus on this talk, I'd like to see a show of hands for, firstly, those who have heard of TypeScript before. Yeah, OK, good, vast majority. Those who have used TypeScript before. OK, a few less. Those that have used JavaScript but not TypeScript yet. OK, a few in the audience. And those who have a JavaScript code base of any size that you want to migrate to TypeScript. OK, there's a few. All right. So that's going to be about half the talk. But to begin with, I'm going to get a bit more of a lowdown about TypeScript. So TypeScript itself is around 10 years old at this point. So it's been around for a while. But adoption is maybe not as fast as Microsoft would have liked, and a lot of the big players in the JavaScript ecosystem. So that's part of my mission here as well today. I've got a personal vendetta to try and increase TypeScript adoption as much as possible across the board, because I really think there's a lot of value that it brings to everyone that uses it, and any libraries that are developed that use it, etc. So if you've used JavaScript before, but not TypeScript, you've likely seen errors like this at runtime. If you're lucky, you will catch these during testing locally or in developer environments, but sometimes they can reach production, which is never good. In the best case, these error messages might occur early on in the error console, either in the browser or in your logs, and occur close to where the mistake happened. But sometimes a mistake might be made and allows data to flow through the application and an error to occur in a completely different place from where the mistake was made. This can cause strange or even dangerous behavior and be hard to debug. Which is never good. So a common theme with these error messages here you might notice is that 3 of them are type errors. And the only other error that's not is actually the sort of error that can actually be caught with static typing anyway. So even when you're just writing vanilla JavaScript without any TypeScript, you are dealing with types in your code. And to emphasize that, there's a quote I'd like to share. Types exist in JavaScript whether you choose to use tooling which can reason about them for you or not. And this is from James Henry, who's a Microsoft MVP for TypeScript. And TypeScript aims to be that tooling by making using types in JavaScript and in the JavaScript ecosystem easier and faster. And also, of course, reduce bugs due to type errors in JavaScript code. And this is how it does it. So TypeScript is a newish programming language now, which adds static types to JavaScript. It comes with a compiler that will take TypeScript code and output JavaScript code, which means that you can use it anywhere that you can use JavaScript. Syntactically, it's what's called a superset of JavaScript, which means that all JavaScript is syntactically valid TypeScript, and TypeScript only adds additional syntax to your code, such as type annotations. I'm supposed to click through. It does not replace JavaScript, Instead, it enhances it. To illustrate this, they have made concessions to account for the dynamic nature of JavaScript, and they've sacrificed what's called soundness. They also closely follow the ECMAScript, which is the standard for JavaScript, which means any new or upcoming features, TypeScript is already preparing and getting ready for. Beyond this, there's lots and lots of tooling. So there's IDE integration with language servers, we've got jump to definition, IntelliSense, auto-completion, refactoring, and of course, type checking, which is the big one. If you're interested in going into these sorts of details a little bit deeper, I highly recommend watching James Henry's talk back from 2018, but it's still as relevant today as it was when he gave it. And here's a graph that I quite like. It really shows how the open source community is starting to recognize the benefits of TypeScript. So this is from GitHub's State of the Octaverse publication, where they do a sort of analysis of open source software in particular. And you can see here that although JavaScript remains top dog and has done for many years, TypeScript has been gradually increasing in popularity. And for the last 3 years, it's been the fourth most popular language in open source on GitHub. Next up, I want to show you what TypeScript tooling looks like in action, what it's like to use and write TypeScript. But before I go into the demo, I'd like to explain some subtle differences between how this tooling works for TypeScript and JavaScript. What you may or may not know is that most editors, including VS Code, actually use TypeScript's language server to add all of their language support for JavaScript. So all of the type information, autocomplete, everything like that is powered by TypeScript's technology. So TypeScript has already made using JavaScript easier, even if you're not writing any TypeScript. That being said, there are still many, many benefits that you will get if you start writing your code in TypeScript and migrating over to TypeScript. Some key differences in the tooling in particular is that when it comes to like autocomplete, stuff like that, with JavaScript, what you're going to get is an approximation using something called type inference. So sometimes the TypeScript language server will be able to say, oh, these are the different properties available. These are the different functions available from the variable that you're using. But sometimes it won't know that information because there isn't enough type information for the compiler to figure that stuff out. So it will give you an approximation. It'll use like fuzzy searching and matching to try and guess what might be possible. Whereas when you use the same tooling for TypeScript, what you're going to get is an exact list of what can be used with that variable. Anything that's not in that list will be a compilation error and will be a type error. So it gives you really good confidence as you're coding that what you're writing is the right thing without even having run the code and just as you're typing it. It's very quick. And of course, when you have things like refactoring, like when you want to take a symbol and rename it, like another property or a function, you can be confident that it's happening across your entire code base all at once. So I'm going to show you quick videos that demonstrate this. So in these videos, I'm going to be using VS Code, which has very good built-in support for TypeScript, and is itself also mostly written in TypeScript. I'm going to be showing this across 3 different files. So all of these files, you can imagine, are in very different parts of the code base. They're importing one another. The class on the left is a generic class that is designed to receive messages and broadcast it to a bunch of different listeners. And so to begin with, let's start exploring the documentation and to jump to definition features. So as we hover over different parts of the code here, for example, this function, you can see a tooltip that starts giving you some more rich information. You can hover over basically any symbol, and it will do this. And this is the same. It'll use the same definition for this because it's the same function. And it will also include documentation. So here there's some JS docs, sorry, and the documentation became visible. If you start changing the documentation, even without saving the file, you hover over an instance of that property, and the documentation is immediately reflected. This will also happen across different files. So you go over to this other file, you hover over foo, and the changes to the documentation are immediately available there, as well as jump to definition working as you'd expect. So it becomes very, very quick and easy to navigate a code base. So you find yourself jumping through files a lot quicker. Next up, I want to give you an example of what it looks like when you rename some things. So to begin with, we're going to rename this function here we're just going to do it manually to begin with. And you can see immediately that a red line has appeared on the code on the right, which is highlighting a type checking error because we're now referencing a function that doesn't exist. If we correct the message, the function name, then you can see the error goes away. But of course, you don't want to do all of these things manually, so instead, you can refactor just by using the language server, write it once, and the change will apply across your entire code base, across however many files are using this. Beyond renaming, we have things like auto-completing and type checking. So you can, as you're writing, you can basically write the first letter of a function, tab complete. It's immediately telling you the types of everything that you need to write in there. If you focus away from the code that you've just written and you haven't actually fully written the correct type for the variable or the parameter here, it's actually telling you what you're doing wrong. So you can tab complete the property that you're missing. Didn't even have to type the first letter, put in the value. Here I've actually used the wrong type. I put a number, but it needs a string. So I can fix that as well, and then all the errors are gone. If I want to add a new property to this custom message type that we're sending everywhere, I can immediately see all the places where I'm creating instances of this type as I'm sending them in parameters are suddenly wrong. So go ahead to all these places, tab complete to bring up the property, and resolve all the errors like that. If I had a typo, if I typed the property manually, of course, it will highlight it as an error, as an unrecognized property, and then I can address it. And then when it comes to actually using these values as well, tab complete the parameter like that, and it becomes available. I can just type things. Of course, these are not that good example because the property names are quite short, but if you have longer method names, longer function names, longer property names, this becomes a massive time saver, and you find yourself writing a lot more faster than you do when you don't have these features available. And then one more example here I want to show you is for some more type checking. So here I'm using refactoring features to rename properties again. And you can see that it renamed them both in where I call send message and where I'm using the values in the listener. Same when I rename the other property, as can be expected. Renamed in all three places. And then if I delete the property, it's also highlighting them errors as I'm sending unexpected properties in the parameter, and I am using a property down below that doesn't exist anymore. So all of this works to speed up your development and catch errors way earlier than you would otherwise find them. So hopefully at this point, if you weren't already, you're convinced that TypeScript is going to be useful to you. If you're coding in TypeScript rather than JavaScript, you'll find errors faster before you even test the code, and you'll just move faster and write code faster. So how would you go about migrating your entire code base? Well, large code bases are going to usually be split up into many modules, likely with many different functions, other members, other exports. And sometimes code bases might be split into many packages as well if you're using, for example, monorepo technologies that allow you to split things up into packages. Do you have to migrate everything in one go? Well, that would be completely infeasible because for any large or medium-scale project, you'd have to put everything on halt. You'd have to stop all other development to focus on the migration. Otherwise, you're going to get conflicts all over the place. So that's just not feasible. But you may have heard there are compiler options in TypeScript. Could that potentially help you migrate a bit more gradually? So yes, there are compiler options that allow you to, for example, reduce the strictness of the checks that it's putting through. It'll complain about less things about your code. It will allow a little bit more uncertainty by reducing the soundness. So could you start off with less strict settings, convert everything to TypeScript, and then gradually increase the strictness over time? Well, again, unless you have a very small code base, this is not very practical for a number of reasons. You still need to migrate every .js file to a .ts file, And even with the least strict settings possible set for the compiler, it's still likely you're going to face a very large number of type errors that you're going to need to address. So doing this all at once is almost as impractical as doing it all at once with strict settings. Beyond this, at some point in the future, you're probably going to want to increase the strictness by gradually changing these compiler settings to try and catch more problems and increase the soundness and increase your type safety. However, each time that you do this, you're likely to need to investigate and address many, many problems across your entire code base, again, in one go, which can be a massive undertaking. I don't know how many people have experienced adding, for example, new ESLint rules to your code and then having to address everything everywhere before you can even merge the pull request that enables the rule. You'll face exactly the same sort of issues here, and it's very frustrating. And I've taken this approach with the TypeScript compiler in other projects, and it is just not practical at all. So I do not recommend it. OK, so that's not useful. But you may have also heard that TypeScript has the ability to turn type checking on for JavaScript files. So you can instead of using type annotations with TypeScript syntax, you can specify the types of variables and functions using JS.comments. And can this be used to make migration easier? So the first way of doing this, you could, for example, enable the check.js option, which would run type checking across all of your JavaScript files. However, as this would immediately include all of your JavaScript files in these checks, you're going to face a pretty similar problem as if you had migrated all of your code to TypeScript in one go, which is you're going to be faced with compilation errors and static type errors all over your project that you have to resolve, again, all in one go, which is not feasible. So we don't want to put all of our development on hold, and we don't want to do that. Beyond this, given that you actually have to use JS.comments to write your type annotations instead of TypeScript syntax, it's a lot more verbose and harder to read if you take a look at these two examples here. And this is particularly the case when you're referencing types that are defined in other files. And there's no way to define more complex types like objects with nested objects and arrays and those sorts of things other than in TypeScript files. So you have to import them, and then you're faced with having to use that syntax. OK, so it might not be this useful to do this, but maybe if you start doing this on a per JavaScript file basis, you might have a better job. Could that help? So that is also something that you can do. You don't have to run type checking on all of your JavaScript files to be able to import them into TypeScript. Instead, you can just allow TypeScript to import any JavaScript file, and then only add a comment, this TS-check comment, at the top of each JavaScript file that you want to enable type checking for. However, this can be quite dangerous, as when you import JavaScript files that don't have the TS-check option, so don't have type checking, if TypeScript struggles to infer the type of something, if it struggles to figure it out with the information that it has, it will default to using the anytype, which is also reducing soundness and will reduce the type safety of your application. And this blurs the type safe boundary. So to summarize, type checking JavaScript files can be useful. However, JS.doc type annotations are really verbose. It's not possible to define complex types in JavaScript modules. And either all of your issues need to be addressed and resolved at once, as you would if you migrated everything, or you reduce the type safety by not running type checking on all of your JavaScript files. So none of that sounds very great. Is there a way to migrate to TypeScript across your entire project that doesn't have any of these downsides? One that allows for your code base to be migrated gradually, allows for you to use the full set of TypeScript syntax and features as you go, and provides you the best type safety guarantees for code that has already been migrated. And I believe there is. And I've applied this to at least one project with very, very good success. And I'll go a little bit more into that in detail. And the strategy that I use for this is to migrate JavaScript code to TypeScript on a per module, or more granularly, a per function or per export basis for larger modules. Doing things this way allows you to maintain a strong type-safe boundary between code that has been migrated to TypeScript and the code that is yet to be migrated. For cases where you want to import JavaScript code inside of TypeScript code without migrating that file yet, you can use type definition or type declaration files that specify the types of the exports that you actually need to use in TypeScript, and nothing else. And that is kind of illustrated here as the orange. So I'm going to show you a concrete example now of what that looks like, taking a project that is entirely JavaScript and moving some of it to TypeScript while maintaining all the same existing functionality. So this example project that I'm going to run through, and hopefully everyone can see the text. This example JavaScript project has many modules, but we're going to be focusing on just 3. We have foo.js in the top left corner, which is our entry point. And we have 2 library modules, one that's quite big on the right and one that's small in the bottom left there. Our main goal here is to migrate the module in the top left and make that TypeScript, making any necessary changes to other files to facilitate that happening. So to begin with, we'll start by renaming the function, renaming the module to use .ts instead of .js. And straight away, we have our first type error. And this is with the import. So let's fix that. And this is trying to import basically the entirety of the large module on the right here. So we don't really want to migrate this entire JavaScript module because it's big, or this example isn't that big, but imagine that it's a lot bigger. So we don't want to migrate it, so instead we're going to create a declaration file. So we create a new file with the same file name, but with the extension .d.ts instead of .js. We create a type definition for this first function that we're using, which is called addTogether. And we can see immediately that this resolves the compilation error on the first line with the import. However, we now have an error on the second call to the function. And this is because we're giving this function a string as an argument instead of a number. And we've assumed that the argument is going to have to be a number. But if we look at the definition on the right, it uses the plus operator, which of course works for both numbers and strings. So what we can do here is we can use generics to allow the argument to be either a string or a number and return the same type. So we modify the type definition here at the bottom. We introduce a new type parameter t. We specify it must either be a number or a string, use it for both the argument and the return type, and now we can see that the compilation error in our entry point module at the top has gone. Next up, let's look at the next error. So here we're trying to use the toString function that we export from this module. However, there's a compilation error due to unexpected arguments. Now, this is because TypeScript is assuming that we're trying to use the default toString function that appears in the prototype for modules, and which exists for basically every object in JavaScript. But what we're actually doing here is we're overriding that functionality by exporting a different function that we happen to call the same thing. So let's just add a type definition for this string and see what happens. So we create the type definition in the declaration file, and we can see immediately there that the errors in the entry point module have been resolved. We now have one error remaining in the entry point module, so let's start working on that. Now, for argument's sake, let's say that when we look at this function in the JavaScript file, we decide that it's a good candidate to also move over to TypeScript during this exercise, rather than just adding a type definition for it. So what we're going to do is we're going to create another new file that we're going to call the companion file. And this is going to be a normal TypeScript file. We'll use the same name as the module that we're migrating the code from, but we'll just add a suffix .types.ts at the end to distinguish it. This module is going to house any of the code that we decide that we want to move to TypeScript from this larger library file over here. So we just copy over the function that we're looking at right now. And we can see, of course, unsurprisingly, there's a lot of different type errors. So let's address the first function call. If we look at the module on the right, we can see that this is handled by an import from another module, the smaller library module. So we'll just go ahead and import the same thing. Now, unsurprisingly, this also causes a compilation error because this smaller library module is also just written in TypeScript. Just written in JavaScript. So At this point, I'm also realizing, hold on a second, we've now got some duplicate code. That's not a good situation. So let's resolve that by deleting the code from the original JavaScript module. However, we're still going to import it from the companion module. And the main reason that we're doing that is because of this line here. It's because we are exporting it and we're making it available. And we want to maintain compatibility with any of the JavaScript modules elsewhere in our code base that happen to be using this function and assuming that it's reachable by importing this module on the right. So doing things this way means that although the function is now going to be defined in TypeScript, it is still going to be usable by any of the JavaScript modules that happen to use it. So now let's go back to the companion module and fix this compilation error with the import. If we go to the module that we're importing this function from, this smaller library, we can see it's very small. So rather than creating a declaration file for it, we're just going to migrate the entire thing to TypeScript. So we rename the module to .ts, use the export keyword, add some type annotations, and then we're basically good to go. So if we go back to the companion module here, we can see that the import error, compilation error is resolved. Now, if we look at the next two function calls, we can see that they were functions that were defined locally in the large library here. But now they're not actually being used by anything else. So let's just move that over to the companion module as well. Now, the compilation errors that call the functions are gone, and the only thing that we're left with right now is to deal with these type errors where we haven't defined types for these arguments. So let's go ahead and do that. We'll add some types and also some return values for the bottom two functions. And now we have some new errors. So let's start addressing those. If we look at the first one, if we hover over it, we can see that the problem is it's because the return type of make pair is different to the type that we've given to value, which is from the argument definition. So to solve this, we could either avoid using assignments altogether and just pass the result of make pair as an argument to the next function. But for clarity in this demo, I'm going to introduce a new variable that will solve this. So we introduce a new variable called pair, and the type error goes away. But now we still have an error on the next line. If we look at that, we can see it's the same sort of problem, but with different types. The return value of add length to array, or the return type of add length to array, is different to the type that we expect value to be. So this assignment isn't allowed. So instead, we're going to, again, introduce another variable. And with that, all of the errors in this module have now been addressed. So if we go all the way back to our only compilation error right now in our entry point, we can probably resolve this quite quickly. And the way that we do that is just by importing the module, or importing the new definition directly from the companion module, so all the types just work. And with that, all of our errors are resolved. We have now migrated 2 JavaScript modules to TypeScript. We have moved some functions from a large JavaScript module into a new TypeScript companion module, maintaining compatibility with any of the JavaScript modules that are still importing that functionality from that module. And we have created type definitions for some functions of a JavaScript module that we didn't want to migrate just yet. As a result, we've maintained a strong type-safe boundary around the code that we've migrated. And we have TypeScript code that's calling and importing JavaScript code that's calling and importing TypeScript code. And it all happens to just work. So we're now in a position where, as we've resolved all of our compilation errors and the code and the behavior of the application is still the same, we could actually open a pull request and start the process of migrating our code base to TypeScript. To continue the migration of these files, we'd want to gradually move all of the functions and all of the other members from the large JavaScript module on the right over to the companion module until everything had been moved over, at which point we can just delete the old module and rename the companion module to get rid of the .type suffix. Then all the old JavaScript modules that were importing that module will continue to work, and all of the new TypeScript modules that are using the companion module will have import, their import will change to get rid of the .type suffix. And that would happen automatically if you rename the file in VS Code. or any equivalent tooling. So that strategy is pretty good. In that example, we've taken the first steps of migrating our code from being entirely JavaScript to slightly more TypeScript. But in general, how do you prioritize which code you migrate first? Well, the approach that I recommend is to focus on code that changes the most regularly, or code that is referenced and used the most, as that's what will get you the most impact earlier on. As you open pull requests that change something, consider migrating the module that you're about to make changes to first before making those changes. Beyond this, it's a good idea to have a policy or practice where any new modules that you introduce are TypeScript and not JavaScript. And even better, any new functions or any new exports or any new code at all that you introduce to existing JavaScript modules, you instead introduce to companion modules that you create on the side and just import the functionality into the JavaScript module. So if you want to introduce, and you would use a similar suffix like .typed or something like that. So this way, as you begin to migrate more and more of your code base to TypeScript, you don't take any steps backwards and start introducing new JavaScript code into your code base and undoing some of the work you've put forward to migrating your code. Then at some point in the future, you'll hopefully have a situation that looks a little bit more like the diagram on the left, where a majority of your code, or at least all the code that changes regularly and your most important code has been migrated to TypeScript. At this point, it's unlikely that the remaining JavaScript code is going to be migrated if you only follow the strategy that I outlined on the previous slide. So when you reach this point, it's a good idea to put in some effort to migrate the code that is yet to be migrated, the code that changes less frequently, by setting aside a percentage of your time to work on migrating these modules. And often it's also a good idea to finish off the final parts of the migration in a final push or a sprint or a hackathon or something like that, just to get over the finish line. With all that being said, you do need to be conscious of how much time you spend on migrations. Like with any work, there is a cost and a benefit to doing these migrations. If you spend too much time on migrations instead of the other work, then you may slow down your team's progress instead of speeding it up. I have found, however, that if you get the balance right, if you focus on migrating the right things, then it's quite likely that overall your team's productivity and code quality will increase early on, even when you've migrated only a small amount of your code base. And of course, this only increases as the more and more of your code base that's migrated. I've taken this approach on two large-scale migrations with between 5 and 7 full-time developers on each project, and in all cases, we found benefits, like within the first few days, first few weeks of migration. So, and that's including the learning curve for developers that haven't written TypeScript before. So I want to leave you with a few other tips as well. Firstly, migration work should always be in dedicated commits. You always want to separate it from the work that you do to introduce new features or address bugs. This is very important when it comes to code review. You don't want to mix these things together, because when it comes to the code changes that migrate to TypeScript, they need to be matching in features and logic to the other code. And mixing the two can get a little bit harder to review. So always keep them separate. And you can have separate pull requests or separate commits in the same pull request, whichever workflow works for you. It's a good idea as well to increase your test coverage before migration. Higher test coverage decreases the chances of something being inadvertently broken if you migrate something incorrectly. So the higher your test coverage is, the better prepared you are going to be for a large migration. Another thing that I've come across in a lot of projects before is importing from modules and assuming that they have the .js extension. So definitely make sure that you go through all of your JavaScript files and make sure that they're importing just the module name and that they don't include the extension. Otherwise, when you start making these migrations, and in particular renaming modules to use the TS extension, things will start breaking. Definitely enable source mapping. When you're running code that's compiled from TypeScript in the browser or in Node or wherever it might be, and you have exceptions being thrown, or you're stepping through your debugger, it can be a little bit tricky to see, or you won't be presented with the original source code, of course. You'll be presented with the code that comes from TypeScript. Most of the time, this will be pretty similar, but there will be some cases where they're quite different. And outputting source mapping allows the browser or whatever's running your JavaScript code or your debugger to map the code that's being run to the code that produced it, so that you can step through and use all of those references. And then finally, this is probably the most important piece of advice that I can impart on you, which is do not use this type at any cost. There are always alternatives to using it, but using this type, it reduces soundness. It makes it much more likely that you're going to introduce type errors that are not caught by the compiler. Unsurprisingly, there are, of course, linting rules that you can enable for most linters that will complain if you start using any. In most cases, you probably can use something like unknown instead, which requires you to do at least an explicit type check whenever you use it. So my key takeaways for today, don't relax compiler options. Keep things on the strictest setting possible, because this will just cause you pain and suffering later on down the road. You want to go file by file, or function by function, or export by export, and use type declaration files or type definition files at the boundary where you don't want to do migrating. Start with the code that changes most frequently, which will give you the quickest gains, and all new code should be TypeScript. You want to strike a balance, which will, instead of costing you time, which is usually the case for a migration, will actually save you time. And you want to separate your migration commits and, of course, have high test coverage before doing the migration. Thank you. One more thing, if you're not familiar with my company, Wise, we're a global technology company building the best way to move money around the world. Whether you're sending money to another country, spending money abroad, or making or receiving international business payments, we're on a mission to make life easier and save you money. If that interests you, you want to join the mission, visit wise.jobs, come speak to me, and there's a bunch of other Wises around as well that can talk about it. All right, thanks.
Thank you, Sam. Do we have any questions from the audience? There we go.
You already said that it's good to start from the files that change the most, but if that doesn't seem to make sense, are there any other good places to start, like the most complex code, the most simple utility files?
Maybe, I mean, it really depends on the code base. Other things you could try, code that has been known to cause the most bugs, which might not be code that changes that often. You might want to sort of increase confidence that your developers have in being able to write TypeScript, so maybe focusing on some simpler code first, or like some small utility classes might be a good place to start to help them build confidence. But ultimately, you're only going to really start getting gains when you're working on code that is going to benefit from the functionality that TypeScript provides. So code that is likely to have type errors, or code where development is happening fast and you want all the benefits that you get from the IDE integration.
Mm-hmm. Sorry for taking a second question as well, but some of these type errors can be quite verbose and long. Yes. And quite difficult to decipher. Do you have any tips for developers who are just starting this thing to give them some resources, or just help them decipher these type errors?
Not really, other than keep trying to do it. Like starting with simpler problems, simpler projects, you'll start getting used to and start being able to decipher what these types mean. Of course, there's a lot of good advice on Stack Overflow, a lot of good advice on GitHub as well. The TypeScript project on GitHub is one of the most active projects on GitHub. It has a lot of activity in its issues and a very active community, so that's also another good place to ask questions if you get stuck. But basically, I would say just start diving in. And there is going to be a level of frustration, but there is usually an answer. Unfortunately, the unfortunate thing is with any strict typed language, Some very notorious ones, for example, Rust and Haskell, have all been known to have very difficult to understand type errors. But once you do start understanding them, you do end up getting a lot of time saved in the end. Yeah.
Thank you. I believe we had one question there.
Are there any practical reasons why one shouldn't migrate from TypeScript to JavaScript these days?
Yeah, I would say if for example, you have a legacy project that you are kind of moving away from, for example, in favor of something else, it might not be the best use of resources to migrate that and instead focus on whatever is replacing it. Migrating code, as with any code change, comes with some risk. You might introduce other problems. Other things that might be very frustrating is if you have complex build systems, you have things that integrate with Babel or Webpack in weird ways and weird ways of bootstrapping your application, or weird ways of importing code. All of those things can add to the frustration of moving over to TypeScript. So if you're reaching a point where you're kind of thinking of letting go of an application or sunsetting it already, it might not always be the best use to migrate. Yeah.
One in the back.
Great presentation. Got some good takeaways, so thank you. You talked about increasing the test coverage, and I know many companies like migrate their main code but leave test code in JavaScript. And I kind of want to get your opinion on that. What are the benefits of migrating the test code as well?
Well, I mean, the main benefit I would say would be speed of development. If your test code is in TypeScript as well, then when it comes to writing your tests, you're going to be faster than if you're writing the tests in JavaScript. The code completion is going to be quicker. You're going to get highlighted errors anywhere you've made a mistake, or you're calling a function that doesn't exist. You might, for example, if you rename a function that has some tests for it, the function's in TypeScript, the tests are in JavaScript, and you refactor that, then it'll be correctly changed in all of your application code, which is in TypeScript, but all the JavaScript functions, all the JavaScript tests will start breaking just because they weren't included in it. So you definitely get benefits in terms of speed of development, I would say, mostly more than anything else. Type errors occurring in tests is less of a problem, of course, because the test will fail more than likely, and then you have to fix it anyway. But you certainly get benefits from speed of development, I would say.
Thank you, Jan. A round of applause.